Hi, hello everyone.
Hello.
Let's wait one more minute for everyone to join. All right, I guess we can start. So once again, hi, hello everyone. Welcome to the next edition of Functional World. This is the final edition before the summer break, but no worries, we'll be back just after the holidays with more inspiring session and ready to fuel your Scala knowledge once again. So maybe without further ado, let's kick off this final pre-summer edition of our meetup, and please welcome our today's speaker, Marcin Szałomski from Hapag-Lloyd, as he takes the stage to enlighten us with breaking framework chains with Vanilla Scala. Marcin, that's it from my side. The stage is yours, and good luck. And I wish you all have a great time with Marcin today. Thank you.
All right. Hello, everyone. It's a pleasure. I will talk about minimalist approach to web application development in Scala. Let's start with agenda, setting the presentation scope, sharing the motivation links to the lecture topic, delving into fresh perspectives on similar approaches, reviewing noteworthy libraries for common tasks, showcasing sample code tailored for this presentation. Let's go. Before we dive in, allow me a moment to introduce myself. I've always been a fan of JVM, and it's not different now, except that in recent years, I've been exploring Scala and functional programming with great enthusiasm. Here is a link to my blog and Twitter Mastodon contact. Let me share a few words about the company I work for. And the question, ever bought something from a store or ordered goods? Of course you have, but have you ever pondered how these goods reach the store shelves from warehouses? I work for Hapag-Lloyd, a global leader in container shipping. You might have come across our unique orange containers like this. All right, before delving into the core of this subject, let's define the presentation scope. It's vital to set some questions and establish the context of this presentation. Why might there be a desire for aestheticism and in application development? From where might such a need arise and what drives it? Scala provides many options. This presentation will focus on JVM. We have a vast amount of material to cover, and it's insufficient time to advocate for JVM, Scala, and functional programming. We need to establish certain assumptions who this presentation targets. It's for individuals who appreciate static typing, compile time correctness, and Scala's additional benefits in this area, who are enthusiasts of functional programming, prefer higher level languages like Java, Scala, or Kotlin for corporate business applications, value JVM for its speed compared to interpreted languages, are willing to accept certain compromises as we can't ignore certain weaknesses like a slow cold start, etc., are aware of various solutions to mitigate these issues. Like the first thing that comes to people's mind probably is Gaussian native image. Today, we are discussing the power of aestheticism, essentially why less is more. We'll consider reasons to adopt a minimalist approach, such as avoiding problems where possible, even with available mitigating tools. Recognizing that using these tools often introduces trade-offs, like increased build time or maintaining complex configurations. Understanding that fewer transitive dependencies can decrease maintenance load, addressing updates, dependency clashes, security risks, bug diagnosis, licensing issues, and performance aspects. Before choosing a large framework or comprehensive library, it's important to consider the potential for vendor lock-in and the risks it entails, such as future licensing issues or legacy stack dependencies. Even when utilizing independent libraries, a lean approach using thin wrappers or facades is beneficial. Asceticism isn't about abandoning tools, it's about making smart, simple choices. Defining framework. I mean the toolset for application building. They are everywhere, even within cloud vendor offerings. Vendor locking, yes, it's a concern. Let's look at some possible options. Utilize standard specs like cloud events or custom model mapping for independence. Implement a thin wrapper on the vendor SDK. Adapt an AIC solution infrastructure like as code, a solution like Pulumi for cloud agnostic code management. And yes, reliance on Pulumi is a trade-off, of course. And now, does a serverless cloud need an application framework? It's situational. Navigating frameworks isn't about choices alone, it's about strategic, flexible decision-making. In serverless cloud world, we rethink web development. Unlike traditional methods, we often need less. Simplicity and lightweight libraries can be key. Below, I've created a table listing functionalities that frameworks like Spring Boot or Play Framework assist us with. I've included the more significant ones, those that first came to mind and as many as could fit on the slide. All this is in the context of a serverless cloud, vendors managed services. Let's see how far we can get. The first thing is MVC architecture, the structured way to organize code, which facilitates parallel development. Very important when working in corporate teams. And that's something we get from library, we'll see. Support for RESTful services, like what framework does for us, mapping HTTP requests to controller methods. And that's this request handling its infrastructure. Data validation, error handling. That's both, as cloud is supporting us with it, but also we have great libraries. We'll do this validation, error handling on different levels. Database and other storage accessing. We have great tools, and also, of course, cloud is supporting these areas as well, RDS proxy, and so on. Scalability and performance consistency. This is, of course, infrastructure. Support for asynchronous processing background jobs. That's infrastructure, because I consider here managed services. And support for unit and integration testing. We have libraries, library of your choice. Security. The cloud is playing the role here, even promoting 12-factor applications, or different solutions like AWS Cognito, or we can use Lambda Authorizer, or AIM for securing resources. But we shouldn't forget that libraries also play a role in this area as well, and community support from both. Before I go to the next slide, all sounds good in theory, but in the real world, we are not building pet projects or hello worlds, but complex enterprise applications. And here, without any frameworks, without, what about different problems like long-running jobs, asynchronous tasks, resilience to failure, etc. Let's see an example. Please see the example diagrams. It's just an illustration. I know the details are not visible. The important thing is to show the general outline. In reality, they will often be much more complex. For example, on the left side, each block with an orange square and lambda sign inside is a serverless function, a simple program in practice, one where the controller will contain simple synchronous code, single responsibility, many simple programs. But altogether, they constitute a complex solution. And for example, when programming something like this, one can't even use zero schedule because AWS step functions will handle these topics for us. We're implementing a workflow here with error handling, retries, exponential backoff, fallbacks, etc. So sometimes we won't need zero or type level stack, but of course it depends. Sometimes we are doing something simple. Other times we are working on a stream-based application and we will use a custom cloud runtime and maybe then FS2 or Zio streams, or maybe we're implementing a concurrent log-free LR cache using Zio STM. By the way, I recommend a recent article by Jorge Vasquez. So standard library. And the question, what's trending? Does the standard library will still attract interests? Indeed, it does. The Scala Toolkit, a new addition to the standard library, launched about a week ago. The set of versatile and user-friendly libraries, which are easy to get started with, ideal for education and writing both simple and complex programs. The selection of libraries includes popular and actively developed ones with a focus on usefulness, user-friendliness, and minimal dependencies. Look, how simple is that? We import the toolkit, create a JSON payload, pass it to the HTTP client, and send our request. Done. We have a response, and that's the entire program. There's no build tool like Maven or SBT. To build the package or run this, we'll use Scala CLI. Just run file name, and that's it, done. Read more. Nice documentation. So, besides the Scala toolkit, there are other toolkits too. For instance, the type-level toolkit for pure functional programming. I'm guessing that Zio toolkit will also appear soon, helping in type-safe, async, and concurrent programming. And now let's try to build our own toolkit based on user-friendly and highly useful libraries with minimal or zero dependencies. We'll use Jsoniter-Scala, parsing JSON and serializing objects to JSON, Mcwire dependency injection, Iron for validation, Sttp for sending HTTP requests, Chimney or Duct Tape for automated transformation of similar nested structures, QuickLens or Dijon for modifying nested structures, and Defects for comparing them, and scalators or whatever with set of tools for testing. We can use Docker with test containers, but we have also great tools that we can implement integration tests without. Before we start reviewing the libraries used, I will briefly outline how it works in the cloud. AWS will invoke our controller via API gateway, so there we have the mapping of HTTP request I talked about, a mapping to a controller method, and it's defined in CloudFormation template. Each controller is an independent entry point, a simple serverless function, simple program. We use a lightweight wrapper to bypass a few limitations, such as no-arg constructors, because we want to pass arguments for dependency injection. So that's how it looks, and simple as that. Let's start with the first library from my list, Jsoniter-Scala, high-performance library, zero dependency for all versions of Scala. JSON parser serializer emphasizes speed, efficiency, and security. Auto-generates secure JSON codecs, customizable, compiles with standards, suppresses JVM-based parsers, rivals top C++ ones in JIT mode even. I can recommend my article where I detail this library. That's it. Paying much attention to Jsoniter's performance, you will find links to benchmarks. Also, you will find helpful tips, a few hints about things and default configurations that we'll likely want to set in practice. Those little things can surprise us when someone starts working with this library. In the references to this presentation, you will find an interesting video about security where Jsoniter played a supporting role as an example of safety. So, and you will find a link to my article too. Now, how it works. So you see, just we have some simple model for the slide, and we set the codec for top level type, and that's it. The rest will be automatically derived. In a moment, I will jump to code. Let's review a few libraries, and then we'll switch. And then we'll go back to slides and again. So the other one is Mcwire. The library streamlines dependency injection with zero boilerplate, ensuring the type safety from the get-go. It simplifies the orchestration of dependencies, fostering parallel development and a clear separation of concerns, terribly crafting cleaner, reusable code. And how it works, simple as that. We have some service, it uses database service. The other one, we inject it, just wire, everything is automatically wired, and we are done. Iron. It allows us to define constraints for our types. In its upcoming version, for now only nightly builds, it also supports Scala freeze opaque types. It's akin to refined, known for similar use with Scala 2, and essentially Iron can replace new type library as well. Why opaque types are not enough, that we still need new type. Opaque types require some boilerplate writing, the necessity of implementing apply methods, the one that would cast an int in value to our opaque type or something else. And here is example. And we don't have to write this apply method. We can just create the type like we see this temperature of 15 or minus 15. So if we have defined those constraints, during the compile time, we see the error with this -5 because we expected positive values. And of course, it works also very well in runtime for unknown values if they are from some requests we validate. And so this boilerplate is macro generated for us. And also what is interesting, there is a proposal to create an alias because we see this method refined type ops, and if it's new type, it would be much cleaner, and yeah, we understand what is it. then it will be, if we have no constraints, it would be pure value just for generating this boilerplate I talked about. Another example, with Iron, we can customize messages and compose those constraints. That's how it looks. And this example shows that we can also use it in a case class. And then if we have our constraints defined like this, and so we parse JSON, the message, if there is an error, will be automatically generated by JSON parser, like we can use it with Jsoniter or whatever else. All right, when talking about all these restrictions, strict mode, fail fast, it may seem overwhelming. Sometimes a bit of flexibility is needed. Maybe we face more ambiguous situations, but we have a strictly defined structure instead. So what to do in such case? Consider these examples. 2 versions of payload, and we want to support both legacy and the new one, or an inconvenient API that sometimes responds with a different data structure, or we want a feature flag that handles requests differently based on specific payload, like I call it dynamic feature flag, that we just handle properly what we get with a strategy. Nothing simpler. Implement discriminator. What we are talking about is essentially a regular enum. And in Scala 3, this could be implemented nicer using an enum. Here we have a sealed, and each object can have different structure. Normally, we define the codec in a simple way, but if needed, so the regular version, like I showed in previous slide, would be JSON codec maker make, and we are done. But if needed, we can add some configuration. We point in this example, we point to our discriminator, it's the sound in this example, and we can add the demapping, what to do when we have one or another. So here you can see, if we get different payloads, we have a cat meowing and dog barking. We recognize objects, we implement a strategy, simple pattern matching, and we're all set. Job done. So we have a bit of flexibility, and still everything is very much restricted. Another library, Sttp. Before we talk about Sttp, maybe this is a good time to jump to code. So I mentioned about, so far I mentioned about Jsoniter, Iron, and Mcwire. Here is a controller. We have some dependencies it has. This is all using standard library, so we have try instead of IO or ZIO or task, whatever. Yeah, this controller has dependencies service, but the service might have another dependency, the repository, and the repository has another dependency, the Sttp backend in this case, and I use different version that shows that this has the swappable backends. I haven't showed yet. This will be in a moment. Yeah, and we have also some configuration injected. So going back, we have all dependencies in here. They're just wired. So if we have our controller using this service and this service, we just say what we have, and everything will be wired properly. So if the service uses the repository and the error handler, then it will be injected where it should be. Now, if I do something like this, we see compile time error. So what I said, that this is compile time safe, And yeah, we avoid the problems we have from the past, some inject annotation, and we could have some runtime issue that some dependencies not wired properly. We see it immediately. The application will not compile, will not deploy this with a problem. And so now I'll fix one of dependencies. The configuration is provided, but it still complains Sttp backend is not provided. Okay. For example, I will remove this handler, and it says after ship handler is not provided. So yeah, works nice. I mentioned about Jsoniter. We have this is Scala 3 and this is IntelliJ. It shows some false positives. This error. So this is the boilerplate I mentioned for opaque type, because the response from the controller is opaque type, this location response DTO, and this is what we have to implement. If I use the iron, I would not have to write this line. And regarding Jsoniter, we define this top level codec, like I mentioned, and everything else, because this is a list of locations, and locations have address DTO, so everything else is automatically derived. I only define the single codec like this. And now if I go back, I mentioned how this presentation mode, how to get there. Iron types. I defined types, and so we have some courier slack. Because in general, I found some random API specification from the internet, and I implemented some demo services based on this specification to showcase what we have here. So this is just a hello world demo application, dummy application, let's say. Yeah, so we have some courier slack type with some constraints, and we have the other country code. Actually, it should be, maybe the name should be different to make it more clear, that it has to be uppercase and some other constraints. Yeah, so we can check where it's used. We use it in multiple places, so then we have those types, and this is not safe because if those are string, because they are, if we swap values, if we have no types, this would be possible that we fetch using country in the first place and then slack the second one, but with this, it will not compile. We can even maybe check where it's used. Yeah, if I do it wrong, yeah, it doesn't work because courier slack country found not what was expected. So let's fix it. So we have type safety, and those types are checked. So if we go to the controller, here we get request query string parameters, and then these parameters are mapped to the type, parsed to the type. So I have this validate, and this validate is implemented by me. So this shows also the flexibility of iron, because the iron has only, for now, maybe this could be fixed, support for either and option and other types, but try was absent. Not a problem. So I implemented this extension method, and I can use try without any issues. So this also demonstrates that if we use some libraries, we can still implement some literal wrappers, extend it if needed, and so on. All right, so I showed, yeah, I showed all three. Yeah, now we can try FastTP. This is a library offering many possibilities, and it's an example of a facade over another third-party dependency, the kind of facade I mentioned earlier. It provides us with an abstraction for HTTP client, but underneath it uses interchangeable backends, plugins, let's say. And for example, we can use Java's default HTTP client or OKHTTP, ZIO, HTTP4S, akka, etc. And if a licensing problem issue arises, or we want to migrate to a new stack, we can change the backend implementation. Usage is very simple. In version 4 of Sttp, it's super simple. See yourselves. It doesn't require any comments, I think. And at the same time, this simplicity is a certain compromise. If someone is looking for more type safety, they may also want to check the other libraries from Sttp family that appear. You can generate not only client code, but also implement a web endpoint. This is also server agnostic. You can swap interpreters. Moreover, you can generate documentation like Swagger. Now it's time for another one, Chimney and Duct Tape. These tools facilitate data transformation between similar structures, automatically mapping identical fields in case classes. They accommodate custom transformers for unique cases. So identical means that's the name, but also the type. And if something has to be computed, then we have to define it. And actually, this is everything we have to do. Here is an example. We have two structures, two types, employee and employee DTO, and we want to map from one to another. And they have more or less the same, but minor differences. So we focus on the unique elements, defining the computation while the rest is automated. So you see how simple it is. And check out also the recordings from the previous edition of Functional Award featuring Duct Tape in details. And going to the code, I can actually show in my controller, I have a method that when everything is executed, finally we map the response to DTO. I created, let's say, this off shortcut that it goes to mapper, just to have it nicer, let's say. And this is a different example than what is in the slide. We map from one type of location to another, location to location DTO, and here we had only one difference. This opened at weekend to compute, and we define how to compute it. But if we don't use, because everything else is handled automatically, but if we don't use Chimney or Duct Tape, then we would have to map everything one by one, like this, and that we map location ID to location ID, name to name, phone to phone, address, items of address, like postal code to postal codes, country to country, very boring. And also we have to do something with this computation. So you see how much boilerplate. All right. So let's go with the next thing. I will check also. All right. Yeah, I will try to answer if there are some questions at the end of the presentation, if we still have time, because lots to cover. So I showed you this in action. Let's go to another one, Dijon. Awesome library. I haven't mentioned that Chimney supports Scala 2, but the migration is in progress, and that Duct Tape is for Scala 3 only. So that's the difference. Dijon, another library, dynamically typed Json library for Scala 2 only, unfortunately, but let's talk about it. Awesome library with vast capabilities, of which I will only present a fraction. It caught my attention particularly for test data work. It facilitates deep copying and merging of JSON objects followed by modifications. This proves useful for preparing data for various test cases. For instance, data can be loaded from a file that's just some imaginary way of loading. And if we have this data, some large JSON, we can, much like the Lens library, refer to some nested element and modify it. Hence, it's akin to Lens in this case. We have a path, and we set some value. We have this modified version of the JSON. If we want to modify something that we have some JSON and we want to use it in multiple places, we need to remember about deep copy to not modify the original. It will be modified permanently. It's not immutable in this case. And regard table, it supports only Scala 2, like I mentioned. And that's why in the sample application, I used a different library, which I will introduce in the next slide. And before I will go there, here's another way of using Dijon. We can define some JSON in this way in code, and then, as you see, we access those fields from this text block like they are properties of an object. This happens automatically. All right, so another library that I used instead, QuickLens. The Lens library offers simplified management of nested data structures. The modifiable field path might be reusable if needed. It supports, I should click, it supports fraction-based field modification, conditional changes, collection element tweaks, and lens composition. Here's an example of a nested structure. And we are creating an instance. Now, let's say we want to give a bonus to each player from all the teams, like this. We just use the path and set what we want to set. And here's the same using this reusable path. Very simple. You can read more documentation. Defects, a truly fantastic library, elegantly showcasing differences within complex data structure. Nothing more to add about its functions. Just let's see. So let's use the structure from previous slide, and two instances of which has slight differences, including a typo and a few different values. Now we try to compare it. So game 1 should match to game 2. It has integration with different test frameworks. So this was for Scala test. And notice how nicely it highlights differences and specifies what exactly has changed. So we got almost to the end. Then I will jump again to the code. I can show you some tests maybe. This presentation mode is strange. Okay. So in tests, yeah, I can just run it like this probably. I implemented a test for the controller, very simple one. Let's see if we have something interesting there. So I use WireMock for connecting to, because this application will connect to some API, use with some underlying service. So I mock it, not mock it, I will stub it in this test, and I can use it like it would make real code. So I'm testing much more than just mocking. This mock is just because I do nothing with this AWS context. All right, so I read some. This is definition of the Swagger, the WireMock, the API, and the valid request. So I where is this valid request? Yeah, here. So I define some request, because this is an integration test. I want to make somehow, let's say, close to a real call, like it would be in the cloud. So I implemented something like this, and I load example event. So this is example cloud events like AWS infrastructure is doing, so a lot of crazy stuff. And from this, I want to modify only a few things like path, let's say, the HTTP methods, query string parameters, path parameters. So I can do this. Maybe in this example, I only modify the arguments from very top, so I could even do this without any lens. But if I want to modify something deeper, then this would be helpful. So I just use this lens to create my test fixture, and then I don't care about the rest. In my example case, I create a request, then I make a call to our controller like it is, with all dependencies like they are, without actually mocking anything. The only thing I mocked, I mentioned, is this dummy AWS context, because I don't care. It's not used in this test. And this checks the expected response in real way. So very straightforward tests, and I can also test some invalid request, check how application behaves. I can also check the validation. I implemented some error handler, because the API sends also 200 requests with some different numbers. So this is example handling, and these tests are actually quite powerful. And that this application is so simple that I test also in this simple way. I also implemented some bonus section that we have example parsing with this discriminator to see how it works, and example of validation. So I will maybe make it hidden. Example validation. So here we have some structure, and I defined some example constraints using iron, some types, and now those are opaque types, and exceptionally there is a comment. There is some known issue that for now, at least for those iron constraints, and this is a method from iron, we have to define also a codec for this type. In the future, probably this line will be not necessary. And now I use my constraints in here. And if I want to parse something, if I get wrong data, we see this message comes as it should. And it's defined because I can customize the message of this validation. So yeah, I showed you this, and maybe let's go again to the project, the controller. So I created a structure. The structure is quite simple. This is hello application. There are different things, and everything is grouped close to the subject. So the controller has its DTO next to it. We have a service. I created, let's say, fake structure to some placeholder to show if we have more services. So the service and this location repository location service has some different models. So this is also next to it. And here is yes, example structure, how it would expand to something more complex. And if we go back to the controller, I can show also that we can compose some dependencies. If let's say this authentication module, if I have more controllers, but they all use the same authentication method for accessing some API, then I would not have to repeat. This is some imaginary implementation of this authentication. If I would not have to repeat this dependencies, because I can also wire them from this thread. So here, where is the authentication? Oh, this controller uses app authenticator, and now it comes from this module. So if I remove it, the controller now doesn't work because it complains that API authenticator is not provided, and it tells me I forgot to wire this, and I can add a module. And this is not this cake anti-pattern, because then we had every service in separate thread. In this presentation, I put a nice link next to Mcwire that you can find this article. I recommend comprehensive guide. I call it like this, that you have some, let's say, philosophy and decision making about how it's shaped, and a lot of useful information on dependency injection in Scala. All right, so I think we got to the end, so let's sum up. I've presented a simple approach using managed runtime for serverless application, serverless Lambda, where many aspects of application creation disappear, leaving us only to focus on business logic. We always have the option to use a custom runtime and can build our product as a full-fledged application using heavier dependencies or framework, handling some technical aspects independently. We simply choose the tool according to our needs and requirements. Thank you. And here you'll find some references, a link to example application, to my article about Jsoniter-Scala, also the link to the interesting movie about JSON security. That's it's interesting topic. Dependency injection overview, a nice video from that was Zyword, but it's about overall dependency injection in Scala, I would say. Something about cloud observability if you are interested in, and see also all links from earlier slides. Thank you very much. Thank you for your attention. Back to the studio.
Thank you, Martin, for your time and for your presentation. Guys, do you have any questions to Martin? We can have some delays, so we can wait 1 or 2 more minutes.
Thank you. Thank you for nice words.
All right, I guess we don't have any more questions. Oh yeah, Krzysztof wrote something in the chat. So if any questions will appear, you can always contact Martin via Twitter. You have a link in the chat. Okay, we have questions from Przemysław.
Scala native. There is some ongoing work from Virtus Lab. Scala native is nice, but you need probably more libraries, and the Scala Toolkit approach shows that those libraries are supporting all platforms, but still the number of libraries might be limited, and I would look how the future will look like, but that it would be amazing approach because Scala native is fast, compiles quickly, so we will not spend time in pipelines like with GraalVM, because then the time is a bit longer. We will not have issues with some configuration. But yeah, libraries. So in practice, yeah, I would wait a bit, but it will be amazing approach if we get there one day.
Okay, guys, any more questions?
Thank you very much.
Okay, so as I said, you can also contact Martin via Twitter. And well, thank you for today's meeting. Thank you for joining us, and see you after the holidays. Have a great time.
See you. Bye-bye.